Hi, let us discuss two type of data immutation under data cleaning process. One is log transform based data immutation. Another one is normalization of data based immutation. Log transform. It is used to stabilize the variance and make the data more closely to the normal distribution. So why you want to make normal distributed data? Because normal distributed data, if you see the normal distribution, most of the data are close to mean value. Such type of data is easy to classify or predict under machine learning model. In normal, the raw data collected from the source may not have such a characteristic. It may have large variance. That means the data may deviate from the central tendency value, that is from central value of mean value. That is not good for statistical analysis or machine learning classification or prediction problem. To solve this issue under data cleaning process, we immute the data by doing log transform. The log transform will reduce the variance and make the data distribution close to normal distribution. That is the key idea. The command for those mutation log transform is given here. You can see that we are working on iris dataset. We'll use mutate command in the R environment and want to create new variable called log sepal length under the iris dataset, which is nothing but log transform of sepal length of the original dataset. So what do you want here? We want to create a new variable named as log sepal length, which is nothing but log transform of already existing sepal length data. So this is we want to make mutate. Mutate means we want to instruct or insert in the iris dataset, existing iris dataset. Similarly, normalizing the data also one of the data cleaning process. Under normalization process, we rescaling the data to standard range, which is nothing but 0 to 1. Why we are interested to scale the data to the standard range? Normally in any data set, different variable could take different range value. Those different range value is problem for classification or prediction problem of using machine learning. What is the problem if we have different range value? Suppose one of the variable in the data set is having large magnitude range values. All others are having small range value. Then probably the variable which is having large magnitude will dominate in the learning process and it will bias the machine learning model that will result in improper classification or less accurate classification. To solve this, before feeding the data to machine learning model or statistical model, we need to scale the data such that all the variable will take same range of the values but different values. So that we are doing by means of normalization where all variables in the data set is going to take the values between 0 and 1. So this normalization process is nothing but we'll take any variable x and we'll subtract the mean value of the variable x and we'll divide by the standard deviation. This is called normalization process. To establish this normalization mutation process or data cleaning process, we can use the scale function in the R environment. After scaling the values, we want to make it the values as a data frame and store it into a new variable called iris normalized. So here we are interested to scale only the first four column 1 to 4. Why? Because the first four column only having the numerical values. The fifth column is the species type, which is categorical variable. So we are taking the first four columns and we are scaling them and we are converting them as frame and we are storing as new variable as a new data set iris underscore normalized. Then we can summarize those value and we can visualize. Let us move to our environment. These mutate functions are available in library called dplyr. So we have to first load this library. After loading this dplyr, we will take the mute all function. So this mute all function will mute all variable values by means of what functionality we are applying. So here we are trying to replace the mode value of the data set. After that we want to divide that by 10 and we restore as value. So this one type of mutation. But we have discussed in theory the log transform based mutation, that is we can do by means of this command, that is iris underscore m, that is a new variable, mutated iris data set. We take iris data set and we mute by means of log transform and we'll create a new variable log underscore sample length and we'll store with the value of log of sample length, already existing sample length. Let us run this. So we have now muted and created a new variable. Let us see using head command. So this is already existing sample length, sample width, petal length, petal width, and species type. This is the original data set. Now we created another column log underscore sample length, which is nothing but log transform of the sample length values. So here this value 1.629 some value is nothing but log transform of 5.1. Similarly, the sample length values are taken log and it is filled in the log sample length column. So this is the way we will do mutation by using log transform. Another mutation what we have discussed is normalization based mutation. So here is the command for that, iris underscore normalized. So this is the data variable. We want to store the normalized muted value. And as we have discussed the same command as data frame after scaling the iris data set from row 1 to 4. From row 1 to 4. So let us do this mutation. It is done now. In order to see the effect of this normalization mutation, let us use the summary command for both normalized data set and original iris data set. Then thereby we can visualize the effect. Let's see this. See, the first two command is normalized one and second one is original iris. The first command, you see that all values are taking between 0 and 1, right? Because we normalized. In original case, the values are different. This is the original summary, original iris data summary. This is our normalized data summary. So we can see the impact. So after normalized process, all the data values are taking between 0 to 1 or maybe minus value. So minus value, right? Because we have some normalization process, x minus mu. So under the case of any data set less than minimum value would take minus value. So that is the process, normalization process, what we are discussing.